Welcome to the Trades Podcast, a podcast about the business of home improvement and promoting the trades to young adults.
That's right. It's a great day right here. This is the Trades Podcast. I'm Danny.
And I'm Jeff. Super excited to be here today.
Yep, Jeff, you're back on the West Coast side of things. You're in the BBB podcast studio. Is amazing. And we're going to get some recording in right here because we got some special guests. We got some new, I would say, new technology we've never had on the show. But it's exciting to, learn more about different industries, different ways technology can be used, and what's being used on big projects throughout the U.S. and even the whole world right now. So without further ado, we got Handheld Laser Institute in the house. We got Rex. Rex, how you doing, man?
Good. Glad to be here.
Yeah, us too. Yeah, we're excited to hear again. I was mentioning it. Jeff was geeking out a little bit more about what you got going on and how it's being utilized and all that, but we'll dive into that a little bit later. But go ahead, introduce yourself, who you are, and how you came to Handheld Laser Institute.
Yeah, sure. So my name is Rex Alexandre. I'm the president and principal engineer at the Handheld Laser Institute. I am an Ohio State welding engineer, so always been obsessed with building things, and the cooler the better. And welding seemed like a good way to get into that. So I've spent the past 10 years or so now doing laser welding in the aerospace industry. If it pretty much shoots a laser at a rocket, I've done it, starting with laser cladding on rocket engines for Blue Origin, got into alloy development, large-scale additive manufacturing with lasers and CNC machines and robots, did that for a few years. And then in 2020, SpaceX hired me to start their laser welding program for Starship. So I was one of the first probably 25 full-time engineers down in Boca Chica in South Texas, and built a bunch of automated laser welding and cutting systems, and then got roped into handheld laser welding by Elon. Ended up exploding, becoming extremely popular. We ended up realistically, I think today SpaceX has 130 handheld laser welding systems, hundreds of trained operators, and over 8.7 kilometers of structural handheld laser weld on Starship. So it's been to space, it's come back, it's incredibly powerful when you understand how to use it. But I got tired of seeing, everybody's seen the TikTok videos. They all look fake. Everybody says it's dangerous. Everybody says the welds are weak. And I don't fault anybody, right? It's a new technology. It hasn't been around for that long. There's not that much information out there about it. But here I am, like, looking at the welding industry and how they view it versus what I've done and how I've sent these things to space. And so I left SpaceX 2.5 years ago and started the Handheld Laser Institute. My goal and my team's goal now is really to generate data and help people understand the technology and how to actually apply it in real world scenarios, and not just in, weird looking, crappy Chinese TikToks.
Yeah. And I mean, I haven't seen those TikToks specifically, but I mean, I imagine that there's some controversy because when you have something that's, conflicting towards an industry that's been around for a long time, they're going to have a lot of people, that are going to have to say something, right?
Absolutely.
Well, so a little bit of clarity then, Rex. So on your website, you've got a great looking website, and I was scrolling through some of the reviews, and one of the persons posted a video review, and he was showing some of the things that he's been trying to learn and do by himself, and then he hooked up with Handheld, and you guys gave him some training, and he's showing one of those beautiful little welds that we've been seeing on social media too. So when I look at that, I mean, one, it's a credit to you guys, what you do for training people and whatever their goals or, specific use is. But it's also a credit to where the technology's been. It just seems like a few years ago, I did a tour of one of the training facilities here in San Diego for the construction industry, and they're still teaching stick welding, and then they got a couple advanced classes for some MIG and some TIG. But the technology behind this is really fairly new, isn't it?
We want to thank our sponsor. Superior Flooring Cabinet Designs is one of the landmark family-owned businesses in Encinitas. Owner Cheryl Robertson, with years of customer experience managing her family's hardware and cabinet business in North Park. Cheryl Robertson and the Superior team dive deep to learn about your project and help you find the perfect solution for your flooring and cabinetry needs. Call today at 760-436-0900 or visit www.superiorfloors.com.
But the technology behind this is really fairly new, isn't it?
It is. Yeah. I mean, laser welding as a whole is not new. People have been laser welding since lasers were invented back in the late 60s. But for the most part, it's been fairly low power and it's also been automated historically. I would argue, up until, 2017, depending on who you ask, you might ruffle the feathers of a few Germans who say, we had handheld laser welding systems in our labs back in 2010. In fact, I was at the first international conference on handheld laser welding last week, and I was talking to everybody about the first commercial system wasn't available until 2017, and a couple Germans stood up and said, "No, we had them in our labs," but it's like they were too expensive, they were not safe, they were difficult to operate, and it wasn't really until I would say the past 5 years or so that the cost has come down considerably. The safety is also, I think, better understood at this point, and there's more engineering controls built into the systems. So as a whole, I would argue, maybe the technology at this point is, maybe 7, 8 years old. But realistically, people haven't been paying very much attention to it until probably the past 2 or 3 years.
Okay. Is that because the safety has took a little extra time to evolve, or just nobody knew about it?
I think nobody, I think the biggest driving factor is the lack of knowledge, and there's a lack of knowledge on a number of fronts. Safety is certainly one of them. The other front is applications and how you actually use the technology. So, 5 years ago, there was one company in the United States building and selling handheld laser welding systems, and if you look at it today, there's probably 30 plus companies that are rebranding, for the most part, Chinese pieces of equipment. Um, Large manufacturers will say, Miller or Lincoln, who have traditionally been arc welding manufacturers, are adopting the technology, and their big focus is safety. Everybody's worried about something going wrong, a laser injuring someone, getting sued, of course, which is certainly a real concern. Um, but I think the safety aspects are actually quite well understood at this point. OSHA and ANSI cover the safe use of these class 4 lasers. It's just a matter of helping people understand how to use them and what the best practices are and what sorts of safety features you should look for on equipment in order to actually operate it safely. And I think once you get over the hurdle of safety in terms of knowledge, then you get into the hurdle of, okay, well, what applications can I use it in? How strong are my welds? And that's a much, much larger can of worms to open, um, primarily because nobody's really doing it. Nobody's really out there gathering or generating data on these applications. And for the most part, if a company is, they're keeping it all secret to themselves so nobody else gets ahead of them.
Yeah, that definitely have a lot of questions about the applications of the use. In my early days, I was working at a plating shop, and we had a lot of government uh, small parts come in that had to use a penetrant, I believe. I never got to do
Mhm.
it, but they were testing it, and the dyes in it would show little cracks or pinholes and things like that. I mean, is that something that the Handheld Laser Institute is teaching as part of the protocols, I guess, moving forward in fabrication
Yeah, I
applications?
think, it really depends on the application for a given weld and what the actual requirements are. I would say the vast majority of places where people are using handheld laser welds today aren't necessarily in structural or code welds. Most of it's sheet metal. Pizza ovens, electrical enclosures, signs, really, really basic sheet metal applications where it'd be pretty challenging to do with TIG welding or MIG welding. It'd either be really slow or really high distortion, and so laser makes sense. But we're seeing a growing number of people start to use handheld laser welding in code applications, and I would say that the big applications in terms of code, at least that we're seeing right now, outside of aerospace, because I think aerospace is not really the world you guys live in very much. But the big ones that we're seeing outside of aerospace in terms of code applications are ASME Section 9, so boiler and pressure vessel, whether it's pressure vessels themselves, tanks, or process piping, especially in the world of data centers. And then on top of that, handrails to structural code. But with that, yes, we do penetrant testing, we do visual inspection, and we do destructive testing in our lab as well. Our lab is really set up to generate the data that people need to apply the technology. So we'll develop welds, we'll break the welds, we'll analyze the welds, and it's not just visual inspections and penetrant inspections, but it's also looking at how strong the welds are and how much load they can react before they fail, and helping people plug those into their designs and make sure that the welds are adequate for a given application.
So for a lot of people to visualize that, you've got some big hydraulic presses that'll push
Mhm.
on some parts until they start to break. And
Exactly. Yeah, it's kind of the inverse, right? So we'll pull on them until they break, and then
okay,
we'll measure the force that they were applying when.
okay, awesome.
Yeah, and so it's designed. This is where you're you have been in aerospace in that space, but you're finding that it can be absolutely used in different areas. So when a regular contractor, hears your laser welding, what's their biggest misconception? Is it just the validity and the actual the structure piece of when it's actually put together? Is that mainly the biggest misconception?
Yeah, I mean, I think the two big misconceptions are one, the safety, and number two, the strength. And it's typically in that.
Mhm. And so through these applications, and sometimes it could be like you said, if it's in a sign, these are a little bit like smaller, applications where I imagine pressure or the safety is going to be an issue, but is the safety piece is just mainly behind the laser.
Yeah, the safety piece is mainly behind the laser, and it's mostly focused on the operator, the welder, and people that might.
Yeah, it's interesting, that you mentioned OSHA already has this already implemented on how to handle it and use it. I mean, I think it's always, for a lot of contractors that I've heard through the episodes and people that we had on the show, if it's not broken, don't fix it, in that sense. But this is what we love about new technology. It's new options and new opportunities, like you said, even for companies to grow their business within the states, even though they might be rebranding just Chinese products. What would set your guys' apart from other companies?
Yeah, I would say as a whole, we don't necessarily build hardware. I think it's an
Mhm,
oversaturated market.
mhm.
You've got IPG Photonics, who they were the first one. I mean, they're the father of fiber lasers, and we work very closely with them and a lot of their distributors and a lot of their end users. I mean, we sell their equipment as well because we use them at SpaceX. We're familiar with them. We work with all major manufacturers though. So we actually at this point have even kind of turned into a test house for OEMs for benchmarking lasers against each other. And so people will send us their lasers, we'll evaluate them in terms of safety and repeatability and performance, and then kind of rank them for people, which has been really, really interesting. The industry is growing very, very quickly. We try to be as agnostic as we possibly can. IPG's equipment that we work with a lot, it's not affordable for every shop. I think it's a piece of equipment that makes a lot of sense if it's a high end application where there are code requirements, or you need to buy, say, 10 machines and make sure every single machine is operating the same and making all the same welds. That being said, it's a $40,000-$50,000 piece of equipment, depending on how it's specced out, which doesn't make sense for a lot of small businesses. Um, we've been evaluating a lot of lower cost systems. There's a lot of systems, and I would say maybe the $20,000 range. And then there's some systems that are on, I would say like Kickstarter lasers, if you will. There's a handful of Kickstarter lasers that have come on the market over the past year or so that are, say, below $10,000. Some of them are not really that great. We've found one that we're really, really impressed by. And so for a small shop or a small contractor, something like that might make a lot of sense if you could buy a laser for, say, $6,000 to $8,000. And, it's faster than TIG welding. It's easier to learn than TIG welding. Um, there's a very quick ROI on a piece of equipment at that price range.
So do you think the industry itself as a whole is to integrate more into like the home improvement businesses, people that are installing gates or HVAC for all the duct work, and there's a variety of applications I'm sure it can be used on. Is the price
Mhm.
point of the equipment really the holdup right now?
I don't necessarily think so. It really depends on what the application is, right? I'll tell you, if you're welding ductwork, yeah, a lot of this, because of laser safety concerns, a lot of it needs to be done in a fab shop and not necessarily in the field. There are people working on some creative ways to use it in the field, although it's a little bit challenging for field work right now. There's really nothing stopping you if you're making ductwork assemblies. We've had a lot of different companies come through the lab with um, a lot of galvanized ducting, saying that they want to learn how to laser weld their galvanized ducting. That's typically not an issue. If you're doing ornamental or architectural metals, that's also not an issue. Those are pretty straightforward. There are no code requirements. I would say, probably the bigger hurdle for anybody who's making, say, handrails or stairs or other sorts of structure, really comes down to really state code requirements or AWS, American Welding Society, code requirements associated with those applications. And there are ways to meet those requirements. They're just, I would say, less well known, and the path to getting things certified isn't super clear. Although that's something that we help people with all the time.
Okay, so it also sounds like that some of the regulations have not caught up with the technology.
Yeah, yeah. One of my favorites, actually, this is we're working on writing a paper actually right now, a scientific paper that will be peer reviewed and released, which I hope will help change the tune of some of the people who write the codes. We're also on a handful of governing bodies that write the codes, trying to get handheld laser welding included. But if you look at, say, if you've got anybody that listens to the podcast that does handrails, for example, most people building handrails, if it's carbon steel, it's AWS D1.1 for the code requirements. If it's aluminum, it's D1.2. And if it's stainless steel, it's D1.6. So these codes were all written with arc welding in mind. And one of the bigger hurdles for handheld laser welding in these applications is that these codes, from a structural standpoint, require a minimum fillet weld size of 1/8 of an inch. Now, with arc welding, it's pretty tough to get a high quality weld that's that small. And so there's good physics reasons behind that requirement of a 1/8 inch weld. But we've generated a lot of mechanical data out of our lab that shows that a weld that's maybe 40 thousandths leg length fillet weld is actually just as strong, or can be stronger than a 1/8 inch fillet. So that's a 125 thousandths. So even though your handheld laser weld might be 1/3 of the size, it can actually outperform a weld that's 3 times that size. However, how do you get that information across to the people who write these codes, and the codes aren't necessarily updated that frequently? I think that's one of the bigger challenges in terms of structural applications for the tech.
So, and I imagine the codes are rewritten or updated every 2 or 3 years, not
2 or 3 years would be great. A lot of these codes are of like 5 to 10 years, because
yeah.
for the most part, arc welding technology is quite mature. We've been arc welding as humans for the past 140 years, give or take. Granted, we're still learning, we're still figuring things out, but the fundamental physical principles behind it, and the strength and the failure modes, are very, very well understood.
Yeah, yeah. So you're got challenges on several fronts, though. Cost of
Yep.
the equipment, the code regulations. That yeah, it wouldn't surprise me at all if they're only being reviewed every 5 years. Um, and that's on what level? National level or
It's
the
typically national. Yeah, although I'll tell you, it's interesting to see how different organizations are moving at different speeds. We started what we call the Handheld Laser Users Group earlier this year, and so it's a quarterly meeting of users of the technology, and we talk about challenges and wins, and things that we can do differently, and better use the technology. And our first meeting this year was actually on code requirements. And if you look at boiler and pressure vessel, it's ASME Section 9. They were the first ones to adopt it. The Canadian Welding Bureau has adopted it as a whole. And then the American Welding Society is really the group that's dragging their feet. But I'm pretty excited about this. I met the president of the American Welding Society in Canada at this international conference the other week, and we're actually going to start working with them to more rapidly adopt handheld laser welding. It's a very quickly growing technology, and it's not going anywhere. So we're kind of at the forefront and leading the charge on making this officially included in code books. So hopefully much faster than 5 or 10 years, right? The goal is within the next year or two, it will be officially adopted.
Yeah, I mean, I've had some friends down here in San Diego. There's a NASCO owned by General Dynamics, a shipbuilding company,
Mhm.
and there's only like 3 or 4 in the whole country that build big ships. And I imagine that this technology might take a little while to make it to that level, but it would probably sound like it'd be a great game changer for efficiency and cost, uh, new opportunities for, moving up in the ranks to be
Yep.
able to handle that and the certifications, which is another question. To work on using a handheld laser, is this something that you guys train people and certify them to use?
We do, yeah. So there's no formal certifications because it's not, officially adopted, say by the AWS. But we do training, yeah. So we started out primarily just doing consulting 2.5 years ago, and one-on-one training. We host classes out of our lab in Seattle once a month. It's a 2-day class. And then we've got training videos online. We just started a subscription-based training program with some of our videos. None of that's really going to certify you. The exciting thing I think on the side of certifications is we're actually working with a number of trade schools across North America on some pilot programs for handheld laser welding training and certification. And so it's really a 6-tier credential course, and they're micro credentials. So each course is a couple days at a time. It's very digestible for people who have real jobs and have to actually get things done and can't take a year or two off to go to a trade school and receive that training. Handheld laser welding is, I would say, at least from pulling the trigger and making a weld, a fairly easy skill to learn. I remember going to community college and taking a TIG welding class, and I never welded before. And it took me probably 3 weeks before I could even lay down a mediocre bead. Um, I'll use an example. I hired an assistant, like an office assistant earlier this year. And as part of her interview, when she came on site, we were showing her what we did and how things worked. And she wanted to try welding. And so we put a torch in her hand and showed her a couple of basic techniques. And she laid down a beautiful bead, right? That's not to say that she could make, production welds out of position all day long. That's absolutely not the case. But the learning curve is much shorter to successfully adopting the technology. The
Okay.
the key to actually doing it, though, it's very interesting to me, is really having a deeper understanding of what's going on behind the scenes with the technology. And that's what enables you to prepare your parts correctly and tweak your settings correctly to get a high quality weld.
Okay. So if somebody's already a welder, is this the next level for them?
That's like a trick question. Yeah, yes and no. It kind of depends. These German guys that I talk with, they swear to me that you can't teach a good arc welder to be a good laser welder. And I would argue that's not the case. There's really two different paths to successfully adopting the technology. It is really easy to just throw the torch in someone's hand who's never welded before and just show them a few techniques and a few body positions, and they're making good welds. I would say with a skilled arc welder, they've got some habits that make them very, very, very good arc welders that make them really bad laser welders. And so we kind of got to delete some of those initial building blocks and those habits that these arc welders have, and then they can become better welders. And once you figure that out from a laser welding standpoint, they can bring in all their fabrication and manufacturing experience, which makes them much better and much faster than someone who's never welded before. It's interesting. I probably see a 50-50 split between skilled welders. Some of them are super excited and super curious about new technologies and want to try new things out. And the other 50%, at least when you start talking to them about it, are very defensive and uncertain about the technology. And if you teach them correctly, by the end of the day, they're usually laughing and giggling like little kids and having a great time. But it's just, you know, it's new, it's unknown. It's kind of like when robots show up at the fab shop or in a manufacturing facility and everybody thinks the robot's going to take their job, right? Here you are, you've got some skilled TIG welder who's been TIG welding for the past 20 years and has like really honed in on this art. Um, and here the laser is, and someone with, a week or two of training can make some really, really nice welds. The laser can't do everything, right? Those TIG welders are still going to have their jobs. They'll just get to keep on doing the interesting ones.
That was probably one of my other questions. Will eventually this technology replace arc welding, or is the applications just different enough to where both of them will continue to evolve?
Yeah, I think they'll both continue to evolve. I saw this at SpaceX. I see it with all the people we work with at the Handheld Laser Institute, where, it's the hype curve. People see new technology, they see the capability, they get really excited about it, and then they think they're going to apply it everywhere, and then reality sets in. There are applications where laser makes more sense. There are applications where arc welding makes more sense, and it's really about figuring out how to use the right tool in your toolbox for a different application. I would say there's definitely a clear path for laser welding, I think, to take over a good portion of TIG welding, right? TIG welding is slow. You need extremely experienced individuals to make high quality TIG welds, but you get really high quality welds. The laser is much faster. It lays down similarly sized beads with much less heat input and much less training. I think the area of arc welding that'll be harder for lasers to take over is MIG welding. Right, MIG welding, you can lay down very large beads. This is what's typically used in addition to stick welding, or flux core welding is kind of an iteration of MIG welding for structural assemblies, because you can build very large fillets, you can fill very large gaps. And so that's an area where it's going to be tougher for laser to break into and disrupt it in the same way I think that it can disrupt the world of TIG welding.
Okay, so it really is just another highly technical tool in the box that has its own path right now.
Yes.
Yeah. And I see it like as you're explaining it as a new technology and where it's using less power and it's using less maybe time in that sense. Do you see this helping whether it's fabrication warehouses or even hopefully like you said if it goes out into the trades contractors hands later on in the future more often? Do you see this helping people save money?
Yeah, absolutely. I'll maybe give you three different examples and help me remember all three because we might go down some rabbit holes. I'll give you a SpaceX example. I'll give you, say, like a fab shop example, and then I'll give you a contractor example.
Okay.
So at SpaceX, one of the big structural applications I was really excited about was actually welding on the nose cone. It was really heavily distorted from MIG welding. And we started handheld laser welding, and our goal really was just to reduce distortion. And we did. We went from about, I'll say this in millimeters. Forgive me. I'm sure most of your listeners do not use the metric system, right? We went from about 10
That's
millimeters
actually
of
the name of
distortion.
my company also that I have aside from this, the
Is
Metric
it?
System Entertainment. Everybody must convert, of course.
Everybody must convert. That's right. When I'm picking a wrench out of my toolbox, I don't want to do complex fractions. I want to count by one. It's because I'm dumb. I'm a simple guy. Metric's better.
Mhm.
Everybody's going to try to murder me, but sorry, metric is superior. So we went from 10 millimeters of distortion to under 1 millimeter of distortion, and that was really the goal. But we accidentally 6x'd our production rate on that line. So we ended up combining cells and reducing the number of cells on the line. And then that cell was still faster than everything else. And so we actually shut that cell down for a couple months and sent everybody into other parts of the factory to speed the rest of the factory up. So I think that's a really good example of how it increases efficiency from like a large corporate standpoint. I was training a company in Canada last fall or last summer, and they do like high-end service truck bodies out of aluminum, and they do a lot of MIG welding. There's a good amount of distortion. There's a lot of grinding and sanding to make all those welds flush when they're done. And we used a laser, and we were developing some procedures, and the owner of the company came over and he saw what we were doing, and we talked about how fast it was and the parameters we were running. And he pulled out his phone, and like he goes off into like mental la la land for a minute, and then comes back with his phone. He's like, "Hey, based on this one application, one weld on the service truck body," he was like, "I can save $30,000 a month in finishing time, just sanding and prep off of just one weld." Right. So that is, I think, where the win happens relative to MIG welding. The welding speed of a laser versus MIG is pretty similar. But it's in the post processing where the laser really starts to shine. There's less distortion, there's less spatter, there's less grinding and finishing to shape because the welds are smaller. So that was a really great example that sticks out to me. And then if you look at folks that are welding handrails, which I think is probably more applicable to a lot of the listeners here on this podcast, it's the same thing. You can drastically reduce. It's not just the weld speed, right? It's not just the speed. It's not just the learning curve, the shorter one to start using laser, but it's reducing complexity of your fixturing, right? Where maybe you had before with MIG welding to overcome distortion, maybe you had some big fixture table with a ton of clamps. Well, now you might just have a layout table and you tack it together, and then you can take it off the table and weld it in basically the free space with no clamps and no distortion, and then you also don't have spatter from MIG welding. And so your cleanup time is much less. And so you actually, from that standpoint, could fabricate parts much, much faster across the board with a laser than you could with.
Hmm. Yeah.
Fantastic example of that. I definitely envision that. We're out there installing a high-end gate on a customer's house or the front driveway to get in, and we don't have to put plywood down to protect the concrete because of the splatter or the
Yeah.
nice block wall that it's attaching next to.
Absolutely. Yeah. Now, the one thing to keep in mind is laser safety out in the field, right? And how do you keep passerbys safe from the laser light? Even reflected laser light can be hazardous to humans, and we're really worried about our eyesight. There are, however, a couple of people that are building field tents, if you will. So think about your pop-up tent that you take to the beach or you take camping, where it's a metal frame, you throw it up, and it's got the curtains and the roof around it. There's some people that are building those with laser-safe materials, and so you could go pop that up out in the field where you're going to be welding, and then have a laser-safe area where you could safely and quickly go make these welds in the field.
And spend a year and a half arguing with OSHA about,
It,
hey,
you know, yeah, it's interesting. OSHA, and I find this across the board, is like most people who do safety don't actually know much about lasers. It's a new technology, right? I mean, okay, let's back up for a second. Everything you use in your shop or out on the job site, everything's dangerous. From a fab shop example, I usually tell people, it's the angle grinder or a lathe or a bottle of gas. I mean, what terrifies me the most? We don't use these because we don't do that much work with wood in our shop, but a table saw or a circular saw, I mean, everything you use is dangerous, but the hazards, the PPE to wear, or in some cases, the PPE or clothing not to wear around that tool. And so you can use that tool really without a second thought because you know how to be safe around it. Laser is really the same. And once you understand it, it's just another type of hazard to be aware of. Um, you go back to not that many people know laser safety or laser hazards. OSHA is very much the same. In fact, OSHA just defaults to ANSI Z136.1. And so if you look at the OSHA manual for the use of class 4 lasers, OSHA gives you a summary table of requirements and then says, refer to ANSI Z136.1, which has a lot more details in there. So it is all in there. It is all laid out. And, we don't do laser safety consulting on our end. We'll teach people how to use the equipment safely. There's plenty of other companies that specialize in laser safety. But one of the things that I did early on, because I didn't want to have those arguments, is I actually had a third-party laser safety company come into SpaceX. And I said, hey, look, here's all the applications. Here's where I'm going to deploy it. Here's how I'm going to approach safety. Is what I'm doing correct? And can I get your signature on this to say that it's good? Right. So it can be done, and there's ways to get support and make sure that you are doing it safely so you don't have to have those arguments with OSHA.
Yeah. So that's probably one of the hurdles that'll take some time to make it a little more usable for the average contractor. But I think we've gone through that process for the last 100-something years of, maybe we should have a guard on the skill saw.
Yeah.
Right.
Yes.
Yeah, technology has been, something that's been shifting, alongside a lot of the contracting world, from tools to even the applications, that are on the back end of business. And one of the technologies that we are always fascinated to talk and learn more about specific industries is how AI is implemented and how it really is either usually it's always helping the industry a little bit more. But I mean, I'd be interested hearing what's AI and laser welding. How is that integrated? Is that integrated now? What are you guys seeing in your industry?
Yeah, that's an interesting question. I would say I think this is one area where we're actually not seeing very much the use of AI. And I think one of the fundamental reasons for that is there's just not that much of a knowledge base for any sort of large language model to build on. The information's not there. Of course, I think we'll probably see that change over the next few years. At least for now, in the world of laser welding, I kind of see it as inverted. We're not really using AI to help us laser weld, but we are doing a lot of laser welding to help enable AI.
Hmm.
um, Over the past 6 months, I think a lot of the high-end applications we've seen coming out of our lab are actually for data centers and cooling systems, just because the skilled trades and even automated solutions can't keep up with demand. And so this is where we see laser welding really stepping in and enabling faster manufacturing with I would say maybe a slightly less skilled workforce to go build all these data centers that people are trying to create. Will we see AI involved in the world of laser welding and handheld laser welding in the future? I think it's inevitable. Um, I did see something from someone recently where they said, the future of our strategy is enabling people to dial in settings through the use of AI, which I struggle to see how that's going to be done. Just because a lot of people, it's like, oh, well, just take a picture of your weld and AI will tell you how to fix it. It's like, well, a lot of what's going on with laser welding is actually subsurface, right? You don't know what's going on until you destructively test it. So I'm at a bit of a loss on how that's going to work out, but I'm ready to be surprised and amazed. I might be an expert in my field, but I am happily proven wrong. I'm always ready to learn. So nothing as of now, but I think in the near future we'll probably see some.
Yeah, I mean, who knows? They might even use your institute as, like you said, a test ground for something to be debunked or proven wrong, like you said. Yeah.
Yeah.
That's interesting. I mean, well, I saw something recently also. I think it was Mike Rowe talking on a show or podcast in a sense where there's a demand for just even the trades contractors,
Great.
but more specifically in the welding space. Is that something that you're seeing through companies that are reaching out to you of like, hey, we need to get this rolling and get people trained? And who are the people coming into your institute getting trained?
Yeah, that's a good question. I mean, I think everybody's probably heard the same story for the past 20 years is, oh, all the welders are retiring and we're gonna have no more welders and we need more people to do welding. And nobody can really put a finger on what the actual number is. But the trend is definitely there. So I think this is one of those technologies that does kind of help fill the gap. A lot of people I think default to saying, "Oh, we'll just automate, we'll get robots to weld things," but realistically, automation is hard. There's a lot of challenges associated with successfully automating something. Um, and with handheld laser welding, the learning curve is short. It's really applied to a bunch of different applications, and a new user can pick it up and make high quality parts quite quickly. And so I think on a number of fronts, we are seeing handheld laser welding even displace automation in some shops, which is really, really interesting to help fill that gap of skilled workers.
And there's got to be a price break point too. And numbers are way out of my skill set, but you got to pay somebody, train somebody, buy the equipment to be able to do something individually. Um, so that there's an expense there, but you compare that to the robotics that it's going to take to do that without a person, you know, at a
Yeah,
zero.
and just because you buy a robot, they can do it without a person, doesn't mean that the robot's going to be functioning all the time. I love Elon's algorithm. There's a lot of things that SpaceX beat into me that'll never go away. But of the 5 steps of optimizing a manufacturing process, automation's the last, right?
Really?
You gotta delete things, you gotta challenge assumptions, you gotta follow your part. See how you can simplify things across the board, and then comes automation. I'll tell you, I've got actually 2 contractors that I'm working with right now that are doing some pretty big jobs. Both of them have invested heavily in automation equipment both of them have spent individually over $1 million on some just like single pieces of automation equipment that doesn't meet their throughput capacity. And we can come in and say, hey, look, yes, this laser welder might be, 30, 40, $50,000. Um, it's a lot of money, I think, for a small shop. But for some of these large shops that are already investing in automation, you don't have the throughput with some of these larger automated arc welding machines, but you could go buy 5 or 10 handheld laser welding machines, spend a week training, 20 plus guys, and you could be running 24/7 operation, and you could have, 10 or 20x to your output without automation.
Different way to spin the numbers, huh?
Yeah, yeah, yep. It's wild, and it's not just a single use case. We've seen this multiple times now.
Wow. So, I mean, so that really is a pitch for the trades themselves, or, the trades integrated into manufacturing. There's
Hmm.
a lot of similarities in all that. So, yeah, lots of job and growth opportunities for people just getting into that type of work, the welding work in manufacturing using new technology.
Yeah.
Absolutely.
Yeah, I mean, and you've been seeing it through, on all levels too. Like you said, I mean, SpaceX with Elon, that's huge. You're working with, thousands of employees, and now you have companies that are coming to you to have, maybe a handful, like you said, I think you mentioned like 12, people coming in to get trained up and get the ball rolling. But what skills do the workforce need in order to jump into laser welding?
Yeah, that's a good question. Most of the skills I think can be learned really quickly. And our goal over the past 2.5 years has been to make the knowledge or the path to gaining those skills more accessible. Um, so what do you actually need to know to be successful? Number one, I think you need to know safety, right? So we effectively have, I'll say, you use as an example, we have our micro credential program that we're working on with community colleges, right? So what do you need to know? Number one, you need to know how the equipment operates. What are the right body stances? What are the right angles for the torch and everything? And then on top of that, you need to know laser safety. So how do I approach the technology safely? How do I use it safely? And then we get into, okay, how can I repeatably make all the same welds and be, shall we say, a certified or a trained operator in production to repeatably make the same welds over and over and over again with no defects? And then after that, it's how can you become a technician? How do you know how to troubleshoot the equipment? How do you know how to tweak all your process parameters and make a weld that meets your requirements? I would say those are the first probably 3 or 4 steps you need to get into in order to successfully deploy the technology.
Yeah, and that goes for young people, say, coming out of high school. That's something that they would be able to acquire, you think?
Yeah, absolutely. Yep. We're piloting these programs with 3 different community colleges across the country right now, and the goal is to expand it. In fact, we're working with a handful of very, very large organizations who right now will remain unnamed, but I think we'll see this become standardized and rolled out across the board to help people adopt the technology.
Fantastic.
Yeah.
And you just completed like a training camp or something down here in California?
Yeah, so one of the folks that we work with, Demi Knight Clark, she does a bunch of training, and I brought her on board last fall to help grow our training side of things. So Demi's very, very passionate about training youth and getting people to understand welding technology and welding careers to help rebuild American manufacturing, which I absolutely love. And so she's been instrumental not only for the arc welding side of things on her own, but also helping us generate all of this information and the curriculum for handheld laser welding that we're rolling out as well.
Fantastic.
Yeah. Yeah, and were you present for that, or is that something that you have, Demi that kinda takes the head on that?
On that one, because that was arc welding, I was not. Though we've done a number of things for handheld laser welding. Actually, the state of Oklahoma has been a really, really great partner for us over the past 9 months. We've done a bunch of training in Oklahoma where it's been, local businesses, the trade schools, and even companies starting to come up from, 5 or 6 hours away to come to these training programs that we're hosting at community colleges. I want to start making that a more and more regular occurrence where people can come into community colleges, they can learn about the technology, they can try it out and help evaluate whether or not it makes sense for their business. It's all about just making it more accessible, right? I'll be realistic with you. We're more or less a consulting firm. right? Our costs are quite high in order to utilize our lab time and our manpower. And if that was the case forever, then the welding industry is not going to go anywhere. So for me, it's always been, how do we get this information more readily accessible, whether it's geographically or financially, to help people understand the technology. And I think we're making great strides there.
Yeah, the information's getting out, and just like what Demi had mentioned in regards to like the class that was out there in the Hemet area of California, um, the amount of interest was amazing. That she was mentioning, just people that were signed up, and there had to be a class added to it. I think it just shows, one, the interest, the two, the need, and obviously the technology that people get excited behind it, of what it can do, and then again, the new technology that's coming in with laser welding. I think it just all synergetic and all goes together of just, like you said, a uphill uh, um, progress that I think everybody likes to see.
Yeah, absolutely.
Yeah. Yeah.
So I want to backdoor a couple questions for you, Rex, simply
Sure.
so that I can understand, and maybe our listeners can understand some of the mechanics behind welding and welding with a laser welder. So if you're arc welding, do you need oxygen?
Ideally, you don't want any oxygen, right? So with most welding processes, you're actually supplying an inert gas, which displaces the oxygen and keeps your molten metal clean.
So is that the same for laser welding?
It is the same for laser welding, although depending on the material you're welding, you might use a different type of inert gas. A lot of arc welding typically uses argon or argon CO2 mixture, maybe sometimes some helium. With laser welding, depending on the alloy you're welding, you might use nitrogen or argon. So slightly different gas mixtures, but the fundamental concept's the same. We're just trying to keep oxygen out of the weld.
Okay. So over the next 5 or 10 years, do you see us using welding technology and laser welding technology on the moon, on Mars, in space?
Uh, yeah,
Space?
I think it's inevitable. Because of my aerospace background, I have people ask me about this a lot, and there's actually been a handful of startups recently that have approached me saying, "Hey, look, in order to build all these satellites and infrastructure in orbit, I don't really think any real commercial companies are actually focused on doing things on, say, the moon or Mars right now or in the near future, but there certainly is an interest in doing manufacturing on orbit." In fact, we were at the space symposium a couple months ago, and even NASA asked me about it at the show. So I think we will start to see laser welding in orbit. It's going to be way easier to laser weld than it is going to be to arc weld. So I'm actually really excited to see where all that goes. It'll be very, very interesting.
Absolutely. I mean, I think I referenced this once on one of our early shows. There's a scene in I think one of the first Star Wars. The whole planet is buildings. There's no lakes, rivers, anything. It's all
Mhm.
buildings. Who built those? Tradesmen.
Yep. Yeah. It'll
You know,
it'll never
tradespeople.
it'll never go out of style. You'll always be able to make money as a tradesman.
Yeah, yeah. I mean, um, and right now, I think as the Earth as whole, all the countries out there, there's a massive amount of space trash out there. Satellites that are not operable anymore, right? All
Yeah.
those are resources that at some point will become quite valuable for the next level of um, building in space.
Yeah, you just have to be able to make an orbital shipyard and capture them and dismantle them and reprocess them. Yeah, there's there's a lot of technical hurdles associated with that, which has been the short version of my answer to some of these people who have come to me wanting to do that. It's very, very challenging, but I think we will see demand, and we're almost certainly going to see people doing it in the next few years.
Absolutely, and it could be that young person that just got out of a high school, went over to the community college, got a certification in laser welding. He's been doing it for 5 years now. He's the perfect person to go up and start the next level of our space travel, utilizing stuff that we already have.
Absolutely.
You never
Yeah.
know what a career path can develop just by getting in the
Yeah.
trades.
Yeah.
It's amazing. Yeah, I mean, just listening to this technology and what the institute that you guys have, the Handheld Laser Institute, has been able to kind of build, but also just even from your background and being able to put it in other people's minds, hands, and training, it's gonna make a lasting effect for a lot of contractors or companies that are interested in these type of, you know, new developments. So I mean, it's exciting. So I mean, if you were going to give a piece of advice to a contractor out there, whether it's towards your laser welding or just in general, what would be some advice you want to give them for the future?
Yeah, I mean, I think the big thing is just to stay curious, right? This is one of the big things that was hammered home to me at SpaceX as someone who came in as an expert. Um, you got to question what you know, and just because you know a way to do something doesn't mean it's actually the best way to do it. You know, a lot of experts just tell you the way that they know it can be done because they did it one time, but there almost certainly is a better, faster, simpler, less expensive way to do it if you just think about it enough. And so that's really what opened my eyes to handheld laser welding. And I would say it applies not only to handheld laser welding, but throw what you know out the window and be willing to try new things and be willing to be proven wrong with that curiosity because it'll take you a long way.
That's
Solid,
great.
absolutely solid advice.
Yeah, that's great. That's great. So we got something that's always like been trying to finish it up with some really good insight, just to know a little bit more about you. And but we call it the lightning round. Are you ready?
I'm ready.
All right, cool. We got about 5 questions right here. What's the coolest
Okay.
project you ever worked on?
Oh man, the coolest project. I mean, undoubtedly, it's hard to top Starship, so we'll go with that.
Awesome. Yep. And what's one technology every contractor should watch?
Should watch? I mean, shoot, I'll be biased. I'm going to say laser welding. Well, lasers generally. It's not just laser welding, right? You're seeing laser cutting, laser cleaning. I mean, shoot, I got a vintage. I picked up a vintage Porsche a couple weeks ago, or should I say, pieces of a vintage Porsche. It's a big project, but one of the things is, I was looking at laser cleaners, and then all of a sudden I come across a video where there are people laser cleaning paint off of wood, and I was like, "Hey, this." I was looking at it for metal, but you never know where these things are going to be applied. So you'd be surprised where a laser shows up next.
All right. All right. Biggest mistake contractors make with technology.
With technology, oh man, I'm just going to generalize this: overcomplicating things. Um, I think as humans, we really really like complex solutions, but realistically, in the world of fabricating and manufacturing, the dumbest solution is the best, right? So don't overcomplicate it. If you can do it with a hammer, just hit the thing with a hammer, right? Don't.
Yeah, hit it harder.
Hit it harder. All right. One business book every contractor should read.
Man, I'm an engineer by training and a business person. Been conscripted into that, and I didn't have a choice. The the book that I read a couple years ago that really made a big difference for me was "Buy Back Your Time" by Dan Martell. Such a vastly different mental mindset to operating a business and handling your time as it is to being an hourly or salary employee. So that's been immensely useful to me.
Absolutely. If money weren't a factor, what's one piece of technology you would buy tomorrow?
Man, I don't think it would just be one, it would be a lot. We're always actively expanding our lab and our shop. I think it's actually a handful of things, and none of them are crazy expensive, right? But picking up some proper laser cleaning equipment, get some additive manufacturing technology is fascinating right now. We just picked up a new printer. I'd love to pick up a nylon powder bed printer as well. A CNC machine, man, being able to program things and just make stuff is incredible. I'll throw out one quick thing that I love. If you're a contractor or manufacturer, you do sheet metal work at all, X Tool Metal Fab all day long. This is not a sponsored, comment for them. We bought one full price last year to test in our lab. Less than $20,000. You can laser weld. You can do CNC cutting. Combine that with a little brake press. You can literally make anything you need, whether it's like labels or stencils or brackets or literally anything. We use it every day, and I freaking love it. So, in terms of like a low cost investment to really make a difference, especially if you do sheet metal work, X Tool Metal Fab. That's what I would go buy.
Right. Nice. Nice. That's the lightning round right there. Yeah. Good job.
Right.
Yes, thank you, Rex. It's quite interesting having you on the show today.
Yeah. Thank you. My pleasure.
Yeah, if anybody were to reach out or just want to get some more information or find you online, what's the best way to do that?
Yeah, so our website's handheldlaserinstitute.com. There's a contact form on there. We're on Instagram, Handheld Laser Institute. or you can shoot us an email, info@handheldlaserinstitute.com, and we'll answer all your questions. I'll tell you, there's no dumb questions, right? We've been arc welding for 140 years. We're still learning. Handheld laser welding, maybe 7 years. There are literally no dumb questions. Even the people that build these machines don't know how to use them. So don't be shy. We're here to answer your questions and help you out.
Nice. Love it. Yeah, we'll get all the information out to everybody on the show notes, and reach out to them, because this is an interesting space. Again, if you're a contractor, you're a big company looking to expand your portfolio of assets, but even just skill sets within your team, it sounds like laser welding is going to be at the head front in the near future, like you said, in the next couple of years.
It's not going away.
Yep. So exciting. Thank you again. This is a trades podcast. We can't wait to share this out with everybody and share it with everybody that you think is interested in this. And we'll see everybody next time.
Absolutely. My pleasure, guys.
Thank you.